NASA's lunar base.
NASA, along with international partners and private companies, is building humanity's first permanent lunar base near the Moon's south pole.
This base will serve as home to astronauts from the Artemis program, who will live and work there to explore the satellite, conduct scientific research, and pave the way for future missions to Mars. The project follows a gradual, three-phase approach to test technologies, learn from experience, and safely and sustainably increase capabilities.
Phase 1, Learn, Test, and Build, now through 2029. In this initial stage, the priority is to rapidly and reliably increase lunar activity. Up to 25 missions are planned, including approximately 21 landings, which will deliver about 4 tons of equipment. Robots and unmanned missions will explore the region, test technologies, and prepare the terrain. Companies like Blue Origin, Astrobotic, and Intuitive Machines will send landers, landing modules, to deliver scientific payloads, demonstrate precise landings, and test propulsion systems. Drones called Moonfall, inspired by the Ingenuity helicopter on Mars, will fly over difficult terrain, such as permanently shadowed craters, to map the area and search for water ice. Unmanned rovers, such as Viper, will analyze the soil in search of volatile resources, while lunar terrain vehicles, LTVs, will begin to demonstrate mobility. Energy technologies, such as radioisotope heating units, and orbital communication networks will be tested to survive the long lunar nights and ensure connectivity with Earth. The goal is to understand the hostile environment with abrasive dust, uneven terrain, and extreme temperatures and reduce risks for future missions.
Phase 2, Initial Habitat, 2029 to 2032, leading to the lessons of the previous phase. NASA moves on to assembling basic infrastructure. Up to 60 tons of cargo will be delivered in approximately 24 landings, using landers of varying sizes, the first elements of semi-permanent habitation, expanded solar power systems, and nuclear power demonstrations, such as radioisotope generators to provide reliable electricity even in darkness, begin to emerge. Pressurized rovers, developed in partnership with agencies such as Japan's JAXA, will allow astronauts to travel for weeks in a protected environment without needing to wear a spacesuit all the time. Logistics and terrain preparation. Rovers will move cargo, excavate regolith, lunar soil, and help build the initial bases. Surface communication networks, similar to cell towers, will expand coverage and reliability of connections. This phase marks the transition to longer stays, with astronauts spending weeks working on the Moon.
Phase 3, Sustained Human Presence, 2032 onwards. Here, the lunar base becomes a permanent reality. More spacious habitation modules, with advanced life support systems, will allow for regular crew rotations. Nuclear fission power systems will provide constant energy, while in situ resource utilization, ISRU, will begin extracting oxygen, water, and hydrogen from the lunar soil, as well as producing building materials using 3D printing and other techniques. Advanced pressurized rovers and robust logistics networks will support continuous operations, delivering up to 38 tons of cargo per year. Unmanned cargo return capabilities will bring samples and equipment back to Earth. With this, the Moon transitions from a site of short visits to an outpost where humans live, explore, and sustainably produce resources, paving the way for missions to Mars. The entire project involves global collaboration, commercial industry, and academic innovation. The challenges are significant dust, extreme cold, and the absence of an atmosphere, but the rewards include new scientific discoveries, economic benefits, and the advancement of human presence in space. The lunar base is not just a destination, it is the next step toward making space exploration sustainable and accessible to humanity.